Hi, everybody. My name is Mrs. Cummings, and I am the teacher for the summer mini course this summer. I created this because I'm a pre-AP Algebra 2 teacher, and I knew there were some skills that I really wanted kids to come in being refreshed on and already remember how to do, so that when we start the first part of pre-AP Algebra 2, it doesn't have to be a struggle. It can be when you've let your brain go to mush all summer. And really, even last year, with a lot of remote learning, even by people who didn't want to, but were just forced to during the phase-in and during some other times in the year where we had to be asynchronous. I'm not 100% sure that everything is as saved in your long-term memory as we would hope. So this is kind of also giving you a chance to learn something for the second time if you didn't really learn it very well the first time. So what we're going to start with today is working with all different types of equations, mainly equations that have only one variable. At the very end, you'll see a couple of examples that are more than one variable. We're sticking with just mainly linear functions, not linear functions, linear equations, equations that have one letter and no powers, just straight up first power. So what we're going to start with are some ones that I think I'm not starting with easy ones because the easy ones, you don't need practice on those. One-step equations, even two-step equations. I don't think you need help on that. But looking at ones that require some extra steps, maybe just look a little different and you might not know exactly how to handle them. We're going to work with those first. So I have 3 examples. All of these examples come straight out of the Delta Math online software that your assignments are made up out of. So I wanted you to get used to the way to see a problem in Delta Math, and I'll talk to you about how to input that answer when we get to each problem so that you feel comfortable using the software. Feel free to ask me any questions on my Remind if you don't know how to input something. And remember, there's no risk in the summertime at getting something wrong. There's no penalty. If you get something wrong, you get a second and a third try. If that doesn't work, there's still no penalty. So this is the time to take risks and see if your strategies work for you or whether you need to rethink a strategy. There's help videos on most all of the questions. So if I taught it one way, you tried it, it didn't make sense, it didn't work out, watch the help video. It may approach that problem in a different way than me, and it may make more sense to you. And so then there's 2 methods that you have learned for doing a particular problem. So we're going to start with this one, and this says solve for x. So if you notice, x is the variable in this equation. The equation has a lot of terms on the left side and only a constant or regular number on the right side. Anytime we see distributing, it is a good idea to go ahead and multiply that number 5. This is a 5 into the 4x and into the minus 5. So that's going to give me 20x minus 25. And then I still have a plus 3x minus 1 equals 20. I need to combine like terms on the same side. So I have a 20x and a 23x, I have a 20x and a 3x, that makes 23x. And I have a negative or a minus 25 and a minus 1. So that's going to combine to be a minus 26. And we are going to move the constant, the minus 26, to the other side by adding, which will give us 46. So I end up with 23x equals 46. And I will divide away that 23, that's the coefficient of x, and I get 2. When you type this into Delta Math, you don't need to type x equals, just type in the number 2, submit, and you're done with that problem. So if we look at this next problem, we have a fraction equal to another fraction, and that's a pretty easy problem to do if you remember how to cross multiply. The only trick here is making sure that this minus sign needs to either go with the 2 or with the 9, and it does not make a difference which one. Just please do not forget the minus sign. And the other problem is don't put a negative with both numbers. That's a negative over a negative, which is not a negative. So I'm going to choose to put the minus or the negative sign with the 2, and I'm going to cross multiply 9 times x and 18 times negative 2 and divide by 9. And that gives me the solution for x is negative 4. You'll type in negative 4 into Delta Math and hit submit. This problem is similar, but it's got a little bit more to it because I have x on top and on bottom of one fraction, and I have constants on the other side. So when I cross multiply, I need to make sure that it looks like a distributive problem. I have 9 times all of this numerator, and I have 5 times all of this denominator. And we need to make sure that that's written properly so that we distribute properly and we can solve properly. And so when I multiply 9 times x and 9 times minus 8, this is what I get. And 5 times x and 5 times positive 8. And I'm just going to move the x's to one side, taking them away from the side that they're on. I always like to move the smaller amount of x's to the bigger number of x's, and then I'll move the constants to whatever side that I didn't already move things to. So 9x minus 5x would be 4x, and 40 plus 72 would be 112. And when I divide by 4, I get x equals 28. Please remember, at any point, you can take a solution, plug it in for x in all the places where you see x in that problem, and it should check out to be the solution. If you did it correctly, if I put a 28 here and here, I should get a fraction that at least reduces to 5/9. Now, fractions. Fractions are going to happen all the time in Pre-AP Algebra 2, and they're going to happen in places that you never have even seen them before, like in exponents and in fractions that we graph and things like that. So the more comfortable you are with fractions, the better. Fractions are not supposed to be scary, and yet they've turned into this horrible thing that everyone hates and tries to avoid. Remember, a fraction is just a division problem. This number divided by this number. So I can undo that very easily in 1 or 2 steps. Here we have a fraction on one side of the problem. Here we have a fraction on both sides of the problem. So I wanted to do one of each. And my strategy for how to get rid of these fractions is not the only strategy out there. It's just one. So if there's a strategy that gets you the same answer as I got, but did it a slightly different way, it's probably a mathematically sound way to do it. So I'm going to distribute this 2/3 to both of these. Now, that's not going to cancel out the fraction. This is 2/3 times 2x. So 2 times 2x is 4 with an x, and I'm still divided by 3. That 3 is not gone. Now I'm going to do 2/3 times minus 9. The minus is there. 9 times 2 is 18. Divided by 3 is 6. So this doesn't even stay a fraction anymore. 2/3 times 9 gives us a positive 6. But we had the minus in front of it, so it's still there. Now, if I want to get rid of this fraction, I only have one denominator, so I only have one fraction with one denominator. That denominator, I can get rid of that denominator by multiplying everything by that denominator. So I can multiply 4 times 3. When I multiply 4/3 times 3, it'll cancel out the 3's. And I'll multiply this 6 times 3. So that gives me 12 equals, these 3's cancel out, 4x minus 18. I can add 18 to both sides, and I end up with 4x equals 30. Divide by 4, that will give me a solution of x is 7.5. Now, if I have a fraction in more than one place, let's simplify as best we can. This is the equal sign. So 2 times 1/2 x is just a 1x. 2 times 2 is 4. And this is still on this side. If I combine the x's on the right side, I end up with a negative 2x. And so at this point, I'm kind of stuck. You could move 4 over here and combine it with this, but maybe you don't feel comfortable with that. But let's get rid of this fraction. It is a 4 on bottom that I'm trying to get rid of. So I'll just multiply everything in this problem by 4. Everything. Terms with x's, terms without x's, everything by 4. And that is going to cancel out this 4. Now I will still have a negative 9, right? The negative and the 9 are still on that side. 4 times negative 2x is negative 8x. And 4 times 4 is 16. And so I'm going to add 16, plus 16 on that side. I'm going to move that to the side where the negative 9 is, since those are both constants. That gets me negative 25 equals 8x. Negative 8x, sorry. And I'm going to divide everything by negative 8. Please remember, when you divide a negative by a negative, those negatives are going to cancel out. 25/8 is an exact answer. You're welcome to use a decimal as long as it is a decimal that ends. It cannot be a repeating decimal. It cannot be a decimal that has no pattern to it. It has to end for you to be able to type it in as your answer. So otherwise, leave it as a fraction, and 25/8 cannot be reduced. If you want to put a fraction answer into Delta Math, when you're ready to type the fraction, you just need to hit the backslash button, and it will open a fraction for you. Now, let's remember that not always does an equation have a solution or a single solution. Linear equations will normally have one solution. We've just done 4 examples of those with one solution. But there's also the possibility that it could have no solution or infinite solutions. No solution will happen if you do the math correctly and your variables cancel each other out. The x disappears, or whatever letter in the problem disappears, and you're left with something that is not equal. It is not a true equation. It is a false equation. There's also the possibility that the variables will cancel out and you're left with 2 equal numbers, which would be a true equation. Well, that means we have infinite solutions. I could put any number in for x in all of those places, and it would always be equal. So let's look at an example of each. In this first one, if I multiply -8 to 6x, and if I multiply -8 to 5, I end up with this. If I combine my x's across the equal sign and combine my constants across the equal sign, look what happens. Everything cancels out. I'm left with nothing on one side and nothing on the other side. So that means 0 equals 0. That is a true statement, isn't it? So if that's true and these two sides are equal, that would be infinite solutions. Okay, there is not just one number that I could put in for x. I could put any number in for x in this equation, and it would always be equal. Now, on the opposite side of that coin would be, what if your variables cancel out? Oh, this is a +4. What if this happens and I distribute? And when I combine my like terms on one side, that's a 30, sorry, and I combine my like terms on the other side, and then I bring them to the same side, here I end up with nothing. Here I end up with -1. That's not equal. That's not a true statement. So that is an example of a no solution. So at any point in your assignment, if you come across something where the variables cancel out, it's going to be one of these two situations. Something that is true, infinite solutions would be the answer. Something that is false, no solution would be the answer. All right, we're halfway done with our notes already. Now let's look at the next problem. It's related to that. It gives us an equation that we need to solve for. And if we get one solution, then we're going to be asked to list what that solution is, and then also list something that is not a solution, which would be literally any number except the one that we just got for x. If you solve for x and everything cancels out, remember, if it's a false statement that's left, we'll say no solution. If it's a true statement that's left when the variables have canceled out, you'll write infinite. So I'm going to solve this. It's a good cross-multiplying problem. I'm going to stick a 1 underneath a whole number, which you can always do, and I'm going to cross-multiply. -17x equals 34 times 1, and I'm going to divide by -17, and I'm going to get -2. So my answer to this problem, the solution is there is one solution, and it is -2. When I plug in -2 on this side, I end up with -17 equals -17. So you would say the solution is that there's one solution. There's going to be a drop-down screen that comes into your Delta Math problem after you select one solution. It's going to ask you, what is that one solution, and what does it make the equation equal on both sides? -17. And then I want you to give me some other number, any number you want. Plug it in for x and show what that side equals compared to -17. It will not be a true statement. So just practicing recognizing a solution that works and a solution that doesn't work. Now I need to review you a little bit on absolute value. Back in middle school, maybe 6th grade math, you learned to look at something in absolute value walls. That's what these are called. And you were asked to find what is the absolute value of, let's say, the number 3. Well, absolute value is calculating how far away is this number from 0 on the number line. And if you think about where 3 is located on the number line, it is 3 units from 0. But what about negative 3? How far away is it on the number line from 0? It is also 3 units from 0. These both have the same absolute value. One of these numbers could have been positive in here to get a 3, but one of these numbers could have been negative in here and still gotten positive 3. So whenever you're given an absolute value equation, even if it has a variable in it, what you need to recognize is that inside of these absolute value walls, that could be a positive, this is actually a plus, that could be a positive 46 in there, or it could have been an A value that would have created a negative 46 in there. So if I had a 46 in here, it would equal 46. If I had a negative 46 in here, it would also equal 46. Let's solve for the A values that give us those two things. So this one, 46 minus 4 would be 42, and divided by 5, I believe that gets us 8.4. So you could type in 8.4. Then you also need to consider the solution that where it would create a negative 46 in here. So if we solve that, we get negative 50 on that side divided by 5. And you're going to divide by 5, you would get that A equals negative 10. I also want to talk to you about if you have more than one solution in a problem in Delta Math, you only have one answer box at a time usually. So if you have 2 solutions, as soon as you type in the first answer, and it doesn't matter which one, hit a comma. A comma in Delta Math opens a second answer box. And that will then give you the opportunity to type in negative 10. And those are your 2 solutions. All right, the last type of equation we're going to talk about is where there's more than one letter, and these are called literal equations. The most common literal equation that you guys have encountered would be in some of your science or math formulas, like area of a rectangle. That's A equals L times W. That's a literal equation. It's already solved for A. A is the letter that is currently by itself. Oftentimes you will be given an equation like that, but you're told to solve for a letter that is not by itself. So in our first example here, it says you're going to solve for capital A. Well, look at where capital A is located. It is not by itself, so it is not solved for yet. What it is next to is a parentheses, and don't worry about the fact that this is addition in here. This is a parentheses next to a letter. That means multiplication is what's happening between A and that value. So how do I get rid of multiplication? I divide it. So I'm going to divide away this entire expression that's in parentheses to get rid of it on the side where A is. But remember, that will then introduce it to the bottom of the other side. So I get A equals 2 times capital N divided by D plus M. And that's exactly what you will type into your calculator. You'll type in 2 with a capital N, hit the backspace button so that a fraction will open up, and you can put D plus M down there. And it can be in parentheses or it doesn't have to be. Let's look at this next one. It's a little trickier. Solve the equation for B. So look at where B is. B has a lot of things around it. So think about it. It's being multiplied to N, and it also has subtraction after it. So normally when we have numbers, we would get rid of this subtraction first. And so we will still do that even though these are variables. So now I have capital N times B squared equals 3T plus R. I need to get rid of this multiplication of the N. I'll do that by dividing, and I'm dividing both sides by N. Now I have B squared equals 3 times capital T plus R all over N. And the last thing I need to do is get rid of the squared. How do I unsquare something? I square root it. And that square root is going over this entire fraction. So you're going to type in a square root sign, then hit a backspace so that a fraction will open, and you can write 3t plus r on top and capital N on bottom. Make sure that things that are capitalized look capitalized in your answer. So again, you're going to hit the square root button, which you can find in your Delta Math calculator. Either it'll be a button that you can open, you can click on, and it will pop up in your answer. Yeah, it will. It will. So you'll type this, you'll hit the square root button, then you'll hit a backspace so that inside that square root you will have a fraction. You'll type what you want on top, hit the down button, type what goes on bottom. And then we've got one more. This is a 3, by the way. This is looking a little blurry. You have a formula here, and it doesn't matter what this formula is about. You don't have to understand what the period of one swing of a pendulum is. All you need to recognize is that we have a capital T equals 2 times pi times the square root of capital L divided by 9. L is the length of a string. Oh, this is a G, I'm sorry. G is acceleration due to gravity. L is the length. T is the period. It doesn't matter. The question asks, solve for L. So I need to get L by itself. I'm sorry that my dog is barking. That's really annoying. Okay, so what I need to do is recognize this is 2 times pi times this square root. Let's get rid of the things that aren't attached to the L. Let's divide those away. That's multiplication, so I would undo it with division. So now I have the square root of L divided by G equals T times 2 pi. So I'm getting close to getting L by itself. L is in a square root. I can't do anything more with L until I unsquare root. The opposite of square rooting is squaring. So I'm going to square both sides. That leaves L divided by G equals T over 2 pi. That whole thing is being squared. And now all I have to do is get rid of this G. This is L divided by G. How do I get rid of division? With multiplication. So I'm going to multiply both sides by G. So L is going to equal G times T over 2 pi squared. And that's my answer. And that is it. I'm going to try to end this now. We'll see if it works. And see you guys next week.